Hi, welcome to your lesson on rationalizing denominators. Maybe this joke kind of exemplifies how you feel about this unit right now. It's been very mathy. Well, don't worry, this is the last lesson and we'll get to some more real life math coming soon. For now, let's recap what we've done. We have multiplied radical expressions recently. Here's one radical expression, which is a binomial, and here's another binomial. When you multiply these, you have to remember the rules of multiplying every piece. So we'll begin by multiplying this first piece by this first piece, then the first piece by the last piece, and then two more multiplications, this last piece by this first one, and this last piece by this last one. So remember, there's actually four multiplications taking place here. When you multiply the first one here by this one, you do 4 times 2, you get 8, and then root of 3 times root of 8 is root of 24. The next multiplication is this times this, and in this case we have 4 times negative 1, which makes negative 4, and root 3 times root 3, which is root 9. Then we do the last part here, root 2 times this part, so this one has a 1 in front, so we end up with a 2, and a root 2 times root 8 is root 16. Finally, this piece times this piece is just root 2 times root 3 with a negative sign, so negative root 6. Some of these things can simplify. For example, root of 9 is 3. This 24 can break down into 4 and 6, and this 16, root of 16 is 4. So what we really have is here, we take out a 2, we have 16 root 6. Here we have a negative 4 times 3, which is negative 12. Here we have 8, and here we have negative 6 root 6. These root 6's can be combined. We have 16 here minus 1 here is 15 root 6, and this negative 12 and plus 8 can be turned into a negative 4. That's pretty tough. That was our last lesson. So I hope you're able to figure out most of that and that the steps make sense. We're just recapping this for a reason. It has a lot to do with this lesson. So let's take a look now at multiplying conjugates, which is something else we looked at. These two expressions here are conjugates of each other. We have the same terms or same coefficients. One has a minus sign, one has a positive sign. Those are called conjugates. When you multiply these using the same rules, something interesting happens. So first of all, we do 4 times 4, and we get 16. Then 4 times root 5, which is 4 root 5. Then negative root 5 times 4, which is negative 4 root 5. And finally, that last multiplication, the fourth one, is this times this. When we have root 5 times root 5, it turns into 25 with negative. The interesting thing that happened with conjugates is that the two middle terms will always cancel. All right, when you have two conjugates, you'll end up with two identical middle terms, except for one will be positive, one will be negative. Therefore, they cancel. And you're left with just the first thing and the last thing, which is 16 minus root 25. In that case, 16 minus 5, and that is 11. So those are recaps, but important ones as we move ahead. So what happens when you multiply each of these? Check out this one. When you have a root times an identical root, we end up with root of 25 in this case, and the root of 25 is 5. So one thing to remember is when you multiply identical roots, the roots actually cancel each other out, and we're left with just the number that you see inside. What happens when you multiply conjugates? Well, we just looked at that example. Remember, there's 4 multiplications here, but the two middle ones cancel each other. Therefore, all you have to really worry about is the first number times the first one here, and then the last one times the last one here. So first times first is 4, and root 3 times negative root 3 is negative 3, because again, we saw when we have identical roots, like we have here, root 3 and root 3, the roots will cancel, we'll be left with just 3. So we have 4 minus 3, and that equals 1. So that's something important shortcut to remember when we multiply conjugates like this. Just do the first ones, do the last ones, and the roots cancel. So let's talk about what the main topic of this video is, which is what is rationalizing the denominator, because that's our goal here. Basically, look at these 3 denominators here. Each of these fractional denominators have a root sign there, or a radical. And as we know, most roots are irrational. Unless they're perfect squares, they're irrational. So right now, these denominators are irrational. Our goal today is to rationalize the denominator. That would mean to take an irrational denominator and make it rational. All right, basically it is, you should remember that radicals are not convenient when in the denominator. So again, our goal is to get rid of these radicals, and by getting rid of those radicals, we will make the denominators rational. So here are the 5 we're going to look at today, these 5 examples, and each of them has an irrational denominator. Here, 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 and here we see all irrational denominators. Let's take a look at each one by one. This one first. All right, so how can we get rid of this? If we want to rationalize it, we want to get rid of that. We can get rid of this by multiplying by a fraction that is the same as the denominator here. So here we had a root 2, so we multiply by root 2 over root 2. One thing to remember here is that any number over itself or divided by itself is just 1. So by multiplying by this fraction here, we are just multiplying this by 1. So it's not actually changing it. We're just going to change what it looks like. We're not going to actually change what it is, because by multiplying by 1, we're not changing what it is. So root 2 over root 2. So let's multiply 3 root 2. So you multiply across here, you get 3 root 2. On the bottom, it's root 2 times root 2. But as we know from what we looked at in the previous part of this presentation, when you have the same root multiplied, it just becomes that. The roots cancel and you're left with 2. On top, we have 3 root 2. So that thing, by multiplying by this version of 1, we were able to turn it into this fraction, and now the denominator is rational. So again, you choose the same root you see here, because that will make those roots cancel, and then it's rational. Next sample. All right, take notes on your page as well. Here we have this similar thing. I see a root 3 in the denominator, so why don't I multiply by root 3 over root 3? Again, those roots will cancel, and we'll have a rational denominator. So on top, though, those things multiplied will have that multiplied by that, on the bottom multiply those two. On the top, we end up with 2 root 5 times 3, because we have this root 5, this root 3, and the rule there is that we multiply the insides like that. So we have 2 root 15, and on the bottom 3, because those two roots canceled and we're left with 3. So we have rationalized the denominator. Next one, sample 3. It's getting a little more complex. On the top, we have a binomial. On the bottom, though, we still have an irrational root. So what are we going to multiply by? All right, same thing. We take that whole fraction, we multiply by this version of 1, which is root 6 over root 6. These two will cancel. Let's take a look. So on top, though, we have to multiply this binomial by this monomial, so we have to multiply this piece and this piece by root 6. So notice we've multiplied 2 times root 6, which is 2 root 6, and we've also multiplied root 2 times root 6, which is root 2 times root 6 here. On the bottom, we have root 6 times root 6. Let's simplify some things. This part remains the same, 2 root 6. This here is 2 times 6, so we put root of 12. And on the bottom, we have root of 36. Of course, we know already that root of 36 is 6. So if you saw that in the first step, you could have went straight to the last step. Root 6 times root 6 just simplifies to 6. And here we have 2 root 6 and 2 root 3, because the root of 12 is not simplified. 12 can be written as 4 times 3. And the root of 4 is 2, so 2 comes out, 3 remains inside. That can also be taken a step further. This might be a step that's hard to see, but we have a 2, a 6, and a 2. We can divide each of these things by 2. So divide this by 2, divide this by 2, and divide this by 2. We're just simplifying those fractions, and we're left with this. Sample 4. All right, now it gets a little bit tougher. For most students. Now the denominator is a binomial. We see this irrational root here. But this one's going to be a little more complicated. Multiplying just by root 7 over root 7 would not work. We need to look at this and think, what did we do recently to get rid of roots like this? Well, the answer is to multiply by the conjugate. Because remember, when we multiply by the conjugate, it gets rid of the root, and the root disappears completely, and we're just left with a number. So let's see what happens when we do this multiplication. So we took this fraction, multiplied by this version of 1, because again, this is just 1. And on top, we're going to multiply 4 times that, 4 times that. So we're going to get 4, and 4 times that is negative 4 root 7. On the bottom, remember when you multiply conjugates, all you have to do is multiply the first one, 1 times 1, right here. And the last piece, root 7 times negative root 7. Remember that the two middle things that you multiply here cancel away. So we have 1, and then this times this becomes negative root of 49. And of course, root of 49 is 7, so we have 1 minus 7. So notice by multiplying by the conjugate, this root here disappeared. Multiplying by root 7 over root 7 would not have worked, and you should try that to see. So this becomes this on top, 4 minus that, and on the bottom we have 6. And there's a negative here, actually this is negative 6. Notice the negative can be written here. You could have left the negative down here, but it's more common to put the negative in front of the fraction. It means the same thing. All right, sample 5. A little bit more complex as well. Here we have two fractions. If you have to add them, we'll need a common denominator. You can't add fractions so that the denominator is the same. But each of these has an irrational root. So why don't we multiply each of them by the thing we need to multiply in order to rationalize each one? So in this case, we can multiply the first fraction by root 5 over root 5, because that will make this root 5 disappear. And the second fraction can be multiplied by root 10 over root 10, because that will make this rational or irradical disappear. So here we have 2 root 5 over 5, this becomes 5. And here we have 7 root 10 over 10, because this becomes 10. These cannot be added yet, they have different denominators. But we can make this a 10 so that we can combine these. To make this a 10, we have to multiply by 2. So we can multiply the top here by 2 and the bottom by 2. And then we get 4 root 5 over 10 and add it to that. Then you can combine those fractions to get this one fraction. All right, so this is the 3 examples we gave in the very beginning when I was just pointing out what it means to rationalize a denominator. So why don't you try these 3 now? So here's the first one. Try it out. What do you get? How are you going to rationalize the denominator? How are you going to get rid of that radical in the denominator? Well, hopefully you look back on your examples and you looked at that and you said the only way to get rid of that radical is to multiply by that equal radical. So we're multiplied by root 5 and root 5, top and bottom. This is just a version of 1. And from that you get 7 root 5 over 5. Simple one, all right? That's it. Can't do anything else. But we do have a rational denominator. Next, let's try this one. So you may have been tempted to multiply by 3 root 7, but that's unnecessary. Just root 7 is enough. So root 7 over root 7, that is a version of 1, because those 2 root 7s will cancel. No need to have the 3. Let's take a look. That becomes 10 root 7. On the bottom we have 3, and then we have root 7 times root 7, which just becomes 7. So we have 3 times 7. So on top, 10 root 7, on the bottom, 21. That can't be simplified anymore, so we're done. Last one. Try this one. And remember, multiplying by root 3 over root 3 will not work when you have a binomial denominator. So hopefully you spotted that you multiply by the conjugate, right? Because the conjugate will make everything disappear. So on top you have 2 minus root 3, bottom 2 minus root 3. That is just another version of 1. Let's multiply. 8 times 2 is 16. 8 times negative root 3 is negative 8 root 3. On the bottom, remember when you have conjugates, this would be actually 4 multiplications, but we only need to do 2. The first one and the last one, because the 2 middle terms will cancel away. So 2 times 2 is 4. Root 3 times negative root 3 is just 3, with the negative sign in front. 4 minus 3 is 1, and on top we have this, on bottom we have 1. When we have 1 in the fraction, we can just rewrite it like this. And there's our simplified form for that. All right, hope that makes sense. This is a tough topic, and we will definitely practice a lot more tomorrow to make sure you get this completely.